Hello everyone, my name is Fadhly. Today, me and my friend are going to explain about several subjects. The first one is about quantum computing. Okay, our first subject is about quantum computing. What is quantum computing and how do quantum computers work? Well, the massive amount of processing power generated by computer manufacture has not yet been able to quench our thirst for speed and computing capacity. In 1947, American computer engineer Howard Aiken said that just 6 electronic digital computers would satisfy the computer need for the United States. Others have made similar errant prediction about the amount of computing power that would support our growing technological needs. Of course, Aiken didn't count the large amount of data generated by scientific research. The proliferation of personal computer or the emergence of the internet, which have only fueled our need for more and more computing power. Will we ever have the amount of computing power we need or we want? If, as Moore's law states, the number of transistors on a microprocessor continues to double every 18 months, the year of 2020 or 2030, will we find the circuit on a microprocessor measured on an atomic scale? And the logical next step will be to create a quantum computer, which will harness the power of atoms and molecules to perform memory and processing tasks. Quantum computers have the potential to perform certain calculations significantly faster than any silicon-based computer. Scientists have already built basic quantum computers that can perform certain calculations, but a practical quantum computer is still years away. In this video, you will learn what a quantum computer is and just what it will be used for the next era of computing. The Turing machine, developed by Alan Turing in the 1930s, is a theoretical device that consists of tape of unlimited length that is divided into little squares. Each square can hold a symbol 1 or 0 or be left blank. A read-write device reads this symbol and blank, which gives us the machine to perform a certain program. Does this sound familiar? Well, in a quantum Turing machine, the difference is that the tape exists in a quantum stage, as does the read-write head. This means that the symbol can be both 1 and 0 at the same time. While a normal Turing machine can only perform one calculation at a time, a quantum Turing machine can perform many calculations at once.
Hello, my name is Adin. Now I'm going to explain about entanglement. After a little understanding with quantum computation and quantum computer, we will enter the discussion of entanglement. Entanglement itself is still part of quantum computation. Entanglement allows quantum information to spread over tens of thousands of kilometers and is only limited by how fast and how many entanglement pairs can work in space.
Hello, my name is Dimas, and now I will explain to you a qubit operation. In quantum computing, a qubit or quantum bit is a unit of quantum information, the quantum analog of the classical binary bit. A qubit is a two-step quantum mechanical system, such as the polarization of a single photon. Here, the two steps are the vertical polarization and horizontal polarization. In classical system, a bit would have to be in the one step or the other. However, quantum mechanics allow the qubit to in the superposition of both states at the same time, a property that is fundamental to quantum computing. The coining of the term qubit is attributed to Benjamin Schumachser. In the acknowledgement of his paper, Schumachser stated that the term qubit was invented in jest during a conversation with William Wooders. The paper describes a way of compression states emitted by a quantum source of information so that they require fewer physical sources to store. The procedure is now known as Schumachser compression.
Hello, my name is Bobby and I'm going to explain about Shor algorithm. So, Shor algorithm is named for mathematician Peter Shor. Is a quantum algorithm that is an algorithm that runs on quantum computers that are useful for integer factorization. Shor algorithm was formulated in 1994. The core of this algorithm is how to solve the factorization of large integer or rounded words. The efficiency of the Shor algorithm is due to the quantum efficiency of the Fourier transform and the modular exponential. If an acquainted quantum qubit computer can operate without compromising the noise and other quantum interference phenomena, the Shor algorithm can be used to solve public key cryptography schemes such as the widely used RSA schemes. The Shor algorithm consists of two parts. The decrease that can be done on classical computers, from factoring problems to the problems of other order findings. Then the second part is quantum algorithm to solve order finding problems. The runtime resistance of the Shor algorithm is a modular exponential quantum that is much slower than the classical Fourier transform and the classical pre or post processing. There are several approaches for building and optimizing circuits for modular exponentials. The simplest and most current and the most practical approach is to mimic the conventional arithmetic circuit. The simplest and most current of the most practical approach is to mimic the conventional arithmetic circuitry. One with reversible gate starting with ripple carry adder. Reversible circuit usually use values on order n to the 3, the gate for n qubit. Asymptotic alternative techniques increase the number of gates by using Fourier quantum transformation, but are not competitive with less than 600 qubits because of high constants.